And today we're going to do a brief introduction really about what hyperconvergence is all about. There's a lot of hype in hyperconvergence, forgive the pun, but that's the way it is at the moment. You can't really look at a trade magazine or an online IT website without hearing a lot about hyperconvergence. So really it's to kind of set the stage and talk about why does it exist, where's it come from, maybe a little bit of where's it going, and hopefully from this you'll get an idea as to whether it's something you should look a little bit further into or whether maybe it doesn't fit your business at all. So if we step back just a little bit, which we usually do in these types of webinars, to see really where the problems we're trying to solve have come from. If you think back certainly to when I was in IT initially in the 90s, everything was very much siloed. You had your file server, you had your maybe a database server, you had your maybe an application server, and there was no such thing then really other than in the mainframe world as any kind of shared storage. So, which was perfectly good at the time. We were able to max out servers with individual applications. Unfortunately, or fortunately as the case may be, things changed over time. So servers became more powerful, and we found ways of making use of the spare capacity within these silos. And so basically along came virtualization. Virtualization really, I suppose, was a catalyst for a lot of what has happened in the SAN and shared storage arena when it comes to kind of x86 servers, because without the benefits of shared storage in the virtualized world, you really don't get all of the benefits like the ability to move virtual machines around, the high availability benefits, and so on. So shared storage became the underpinning of a lot of the benefits and functionality we get from virtualization. Now, the thing is, the two technologies were never really designed to work together. When virtualization came along, it added a great level of flexibility to the compute layer. We could move things around, as I said. We had a level of high availability. We were using up spare capacity within our compute layer that we couldn't use up before, and we broke down those silos. The storage technology we had to put in place to underpin that was never designed for it, like I said. It came from the mainframe era, and there was a disjointedness between the two. So while the virtualization layer was very much scale out. Add another server, you add more compute. Add some more servers, you add more compute, etc., etc., etc. And that could scale out as far as your hypervisor could take it. Unfortunately, underneath all of this, you had a very much scale-up oriented design within the storage layer. So you had to think well in advance in terms of how much storage and how much performance you needed to offer up to the virtualization layer in order to design the storage layer correctly. And unfortunately, when you reach the limits of that storage layer, typically there was no way to then scale that out. You had to scale it up. You would again create more silos. So it's almost a step backwards to where now you had a highly efficient compute layer, thanks to virtualization, but now you're creating silos of storage underneath for different application sets, be it VDI or database or exchange and so on. Not great. So that led to where we are today, where IT is a lot more complicated than it needs to be, even though we were promised much more from virtualization. So the buying cycle, while at the server level, it's still fairly linear. We buy servers when we need them. At the storage side, we buy in big increments. So as we outgrow a particular storage technology, instead of maybe being able to add disks, which maybe we can up to a point, but eventually we fill an array, or we outgrow the storage controller capacity, we now have to add more storage controllers, more SANs, and so on and so on. They're incredibly difficult to deploy because SAN technology is not usually, or knowledge is not within the remit of people looking after maybe the servers or the applications. So we need to have SAN specialists. And again, because storage and virtualization are not tightly coupled, they need to be treated separately, designed separately, etc. Management is also disjointed. So we're managing the storage layer, thinking in terms of LUNs, LUN masking, all of the SAN networking that goes on underneath the covers to make all of the storage work, while up above that, we're managing our hypervisors and our applications and operating systems separately. So lots of management consoles. And in terms of scaling, I talked about it earlier, we can scale the compute layer easily, but in terms of scaling the storage underneath, we have these significant events that happen whereby we've outgrown the storage we've purchased. We thought it would last for maybe 3 years. Of course, progress is faster than that, and our storage demands increase faster than we expected. So suddenly we're either out of capacity or more likely out of performance, and we've got to either forklift new stuff in or put in another silo of storage for a new application. Support, of course, is now split across all the different moving parts of this, of which there are many. So we've got the storage functionality itself, we've got the SANs, we've got SAN interconnects, be it fiber or Ethernet or whatever. Of course, we've got the support of the compute layer, the hypervisor layer, the application layer, the operating system layer. And when things go wrong, a lot of finger pointing happens. Now, in an ideal world, how would we design this? Well, one way to look at it maybe is to look at how the cloud service providers scale their infrastructure. So the cloud service providers, like Google and Amazon and Microsoft Azure, have not taken the old architectures and re-engineered them. They've started from scratch. So they've started from the point where they need something to be incredibly agile. There's no point in Google or Amazon, saying like we need to, roll out a new service. It's going to take 6 months. It's going to take a year. They need to roll it out tomorrow, and especially with a DevOps environment where the release cycles are very fast and tied in very tightly with the development cycles, then you can't be waiting 6 months to a year to roll through test and dev and then roll out to production. So you need to be able to react quickly. It's got to be simple. So in terms of the consumption and the management, there can't be one admin looking after every 100 servers or even every 1,000 servers. An administrator needs to be able to look after thousands and thousands and thousands of servers. And from the user perspective, you can't have to worry about what's going on behind the scenes. You just consume and you pay for what you need. Also, when it comes to security, again, security is wrapped up. It's built in. I know there are concerns around security when it comes to cloud, but that's more to do with data locality and such, rather than the fact that most cloud systems are far more secure than you or I could make our own systems, because the economies of scale kick in and the security that can be put in place in the cloud is so much more efficient than we could do on premise. Again, these are the things to aspire to in our own IT. And also when it comes to scale out, of course, the likes of Google and Amazon, they cannot approach their IT in a scale up type of attitude. They've got to be able to add small building blocks with a view to the fact that these building blocks will fail. It's not a case of building in redundancy to the building blocks. It's building in redundancy to the entire system with the knowledge that individual blocks will fail. So let's build it so that we can work around those problems. So if we look back again at that legacy architecture, and I'll call it legacy even though we're all still running it, what do we do to kind of move this forward? So this is where hyperconvergence comes in. The idea that we can converge the complexity that spreads between the storage networking, the compute layer, the hypervisor layer, etc., and wrap it up into a single scale-out offering, then this is a step towards what the likes of, again, the web scale companies like Google and Amazon do. And of course, they have the, I suppose they have the benefit of being able to design their own solution here. For instance, Facebook designs their own TIN. They've even released it under the Open Compute project. But the rest of us can't really take that approach. We don't have the scale. So what if you could actually acquire similar technologies, small building block based infrastructure designed to run your virtual infrastructure that is completely converged, so that the storage layer becomes invisible, the compute layer becomes invisible, and you can literally focus on your applications, which is really where businesses need to focus because that's where the money is made, that's where the productivity comes from, the applications. So Nutanix is really what we're focusing on today because it's I suppose, the leader in this space. But they've started something that a lot of other vendors are really trying to catch up on now as well. So Nutanix started the whole hyperconverged race, and that is what it is now. It's a race, really. In fact, the legacy vendors are even turning around and saying, well, actually, you know what, we can't keep going down the route we were going down. We need to start putting a foot into the hyperconverged market as well. But to see where things are going and where they are going, it's best looking at Nutanix because really these are the innovators in the space. So what we're doing is we're converging all of these individual components down to a single building block. And in fact, Nutanix calls what we're looking at there a block. It's 2U high, fits in your rack. It's got Ethernet connections out the back. And in that individual block, there's typically maybe 4 compute nodes, or servers as we'd call them. Sometimes there's 2, sometimes there's 1. It doesn't really matter. There are different models. And really, what we're doing then is from 3 initial compute nodes, which sit in this block we're looking at, which can take up to 4, we're then scaling 1 node at a time as we want to increase the capacity. And as we're increasing the compute capacity, we're also increasing the storage capacity and the storage performance. And we'll have a look at why that is in a moment. Our virtualization layer sits on top. So basically your favorite hypervisor out of VMware, Microsoft Hyper-V, KVM, or in fact, Nutanix has its own KVM-based hypervisor called Acropolis, can sit on top of this, and your applications on top of that. So in fact, when you use Nutanix's own hypervisor, the virtualization layer is also basically hidden away inside the platform. So basically, we're taking what was a complete mess of 3-tier storage, SAN, and compute architecture, and dropping it into highly converged, or as we call it, hyperconverged infrastructure, which mimics what the cloud service providers do. So really, it is an infrastructure for private cloud, and we gain the benefits that those web-scale cloud providers gain from their infrastructure. Highly agile, very simple to manage and deploy and scale, incredibly secure because less moving parts equals more security equals less attack surface, and as I talked about, incredibly easy to scale out, 1 small node at a time without reaching any kind of bottleneck like you would when you're scaling with SAN. While also actually taking advantage of web services. The idea is that with Nutanix architecture, you can build your own private cloud, but over time, actually consume web services from the big guys like Amazon, Azure, and others. At the moment, the Nutanix platform allows you to connect to those web services for data backup, disaster recovery, and soon also complete application mobility. So that really all you're doing is you're extending your private infrastructure, cloud-like private infrastructure, out onto your favorite cloud provider and moving applications between all of those different locations, be it on-prem or a cloud provider, without any kind of lock-in, so that you can actually choose to use Amazon today, Azure tomorrow, or another the next day. For the moment, some of that is, well, the application mobility piece is really this year, later this year, whereas the data backup to your favorite cloud provider and disaster recovery to your favorite cloud provider is present right now. So where did this come from, really? Where did these ideas come from? In fact, the engineers that helped set up Nutanix came from these web-scale companies, the likes of Google and Azure, Facebook, Alibaba, etc. And they brought what they learned there in terms of building highly scalable infrastructures from just off-the-shelf servers, treating the tin as a commodity, putting all of the intelligence in the software so that you're not tied to any particular piece of tin, making sure that it's scale out rather than scale up, and as I was talking about earlier on, making sure that we're not trying to build high availability into the actual hardware, which makes it very expensive. Instead, we're building the high availability into the system, so the system becomes self-healing. problems occur. They will always occur. But when a node goes down, when a block goes down, when a network fails, the problem is sidestepped and users don't know something happened. And you can, at leisure, replace the broken node, which is something that happens in these web-scale data centers on a daily basis. In fact, I've seen pictures of guys walking around with trolleys of replacement servers, just looking for the red lights, pulling out the bad ones, putting in the good ones, and now the healed system is just rebalanced and carries on working. So it's very similar to the way Nutanix actually works. And of course, all driven by very rich automation and analytics, so that you are gaining insight into how your system is performing, how it's scaling, and in fact, knowing how it will scale in the future based on how it has worked and performed to date, so that you can actually see a runway of when you may need to add another node, add some RAM, add some CPU, and so on, based on your actual application usage, and the ability to do predictive analytics as well, and figure out that if I add this application, will I need to add more infrastructure? So we'll take a little look underneath the bonnet at how the system actually works at a kind of very high-level technical basis. So, as I said, a Nutanix cluster starts with a minimum of 3 nodes. And a node really is just a piece of x86 tin with some spinning disk, optionally, or flash attached to it. So these can be hybrid, as in flash and spinning disk, or they can be all flash. And this is really just a decision down to your individual application requirements. So you start with 3 nodes, which creates the immediately highly available cluster. On top of this, and on top of your favorite hypervisor, sits what's called a controller VM. And in this controller VM is where part of the Nutanix magic happens. So this controller VM is a highly scale-out distributed system, which really creates a grid across all of the hardware that you put this controller VM on. It sees all of the flash storage, all of the spinning disk storage, all of the RAM, and all of the CPU, and creates a distributed storage fabric, which really is an aggregation of all of the capacity available across the entire grid or cluster. Now, this storage fabric is then offered back up to your hypervisor where your VMs run. So as far as the hypervisor is concerned, it just sees a big pool of storage. So VMware will see a big NFS share. Hyper-V will see a big SMB3 pool of storage. KVM will see a big iSCSI pool of storage, etc., etc. Now this is then offered up to your VMs where they can run anywhere across the cluster and gain advantage of all of the performance and capacity underneath. So that storage fabric behaves like a SAN underneath, in that it offers the types of storage service you should expect from a SAN. So we've got native snapshots, cloning, compression, deduplication, automatic tiering between different tiers of storage, so between, say, RAM, flash, and hard disk drive, erasure coding to maximize the usable space across the storage, and resilience in terms of high availability and replication, both asynchronous and synchronous. Data locality is an important factor, one of the features offered by the storage fabric. And that means that, for instance, as data is read or written to the overall pool, so for instance, we have a VM, just apologies, get my pen working. So for instance, we may have a VM running here on node number 1. That VM writes some data down onto the flash on its local storage, which will be RAM initially and then flash. Immediately, that block of data is replicated to another node. So the data exists on 2 nodes, or 3 if that's what you want to configure, at all times. So as the VM reads data, it will always find its data locally. So the VM will be reading off directly attached PCIe flash. So the performance is incredible. If, for instance, that entire node fails, or more likely, that VM actually migrates to another host, well then it will find some of its data there already, thanks to the way the data is distributed. And as it reads data, it may find that some of the other blocks are needed to come across the back-end network, which is 10 gigabit, to the local node. Now this only happens on read, puts minimum impact on the actual backbone, and eventually that VM will find that it has all of its data again on the local node. So again, it is running at fully local flash performance. So the system is incredibly fast, self-healing. The intelligence to do all of these functions like compression, deduplication, tiering, erasure coding, etc., is actually spread across all the controller VMs across the entire cluster. So in fact, as a cluster grows, it becomes more powerful as opposed to less powerful. So each node that's added adds not just its compute power and its storage capacity, it actually adds another storage controller, which means it adds IOPS to the overall cluster. And as well as adding all of those, it also adds compute power to the grid. So when functions like dedupe and compression, tiering need to happen, those functions are basically spread out across the entire cluster, therefore making minimum impact on the overall cluster. So your cluster gets on with the task of running your applications at the highest possible speed and resiliency. So we're moving from a situation where buying infrastructure and buying storage was a lumpy business, an unpredictable business, to a place where now you basically pay as you grow. You pay in small increments. There's an initial outlay, of course, to get yourself 3 nodes, but from there on, no surprises. So you don't need to plan 3 years or 5 years in advance. You can buy what you need right now at this moment in time, and then buy another node in a month's time, 6 months' time, a year's time. And the beauty of this, of course, is that as you buy more nodes, you're buying them at the latest technology. And that's one of the problems with legacy technology as well, is that as soon as you buy a SAN, it's probably 2 years old already because it was designed and put on a price list, put in a warehouse, you bought it, it's now a year or 2 old. It's got a couple of years of support left in it. In the meantime, the compute layer has moved on through the different Intel architectures with more cores, more RAM, more horsepower, and your SAN is sat there maybe with decade-old technology. With this technology, you always have the latest, and as those nodes become obsolete, you drop them off the infrastructure, or maybe you drop them off to test and dev, or you keep running them but you run less VMs on them. The entire cluster can be made up of lots of different generations of nodes, so there's no issue whereby you eventually find yourself having to do a forklift upgrade. Very rapid to deploy. Out of the box, you can be up and running in a matter of minutes rather than hours. Now, of course, the hard work really begins when you start implementing your applications, and that's where you want to spend your time. You don't want to spend your time racking and stacking hardware and putting your hypervisor in place and getting your storage zoned out and offered up. All of that stuff goes away. So you have a functioning virtualization platform running within minutes, and you can get on with the good work of getting your applications working. So very rapid deployment and very rapid to scale. Very simplified management. So this system is designed to be run by IT generalists rather than IT specialists. So the people running your applications, the people running your hypervisor and your application layer don't need to have specialist SAN knowledge. So there are no LUNs in this system. There is no zoning. There is no fiber channel. These are just simple commodity techniques used to basically stand up the infrastructure. And then you just need to know your own hypervisor and your application, and you can get on with the business. I have a quick question here actually about the differences between converged and hyperconverged, which I probably skipped over and I shouldn't have. So we're talking about hyperconvergence here, where the system is designed from day one to have the storage layer and the compute layer and the virtualization layer built in. This is not an amalgamation of separate technologies, which is what converged is. So there are many converged systems out there, which the likes of VCE, or VBlock, the likes of FlexPod, which puts together, say, Cisco and NetApp. There's PureFlex, which I think is an IBM solution. Really what that does is it takes a legacy SAN and puts it in a rack with some off-the-shelf servers, pre-wires it, pre-configures it, and ships it to you. That is still a legacy SAN with legacy issues, in that once you've run out of capacity in that rack, it's another rack, which is another silo to be managed. And of course, you're buying a lot of capacity up front that you may not need day one. It's no different than buying your system separately, other than the fact that an engineer has plumbed the stuff together for you and perhaps, you know, built a reference architecture in order to put the stuff together. Whereas hyperconverged is very, very different. It's not just plumbing a SAN into some servers and offering it up as a, you know, a rack with a badge on the side. So I hope that answers that question for the person that asked it. Now, so management incredibly simple, and we'll have a very quick look at that shortly. The scalability, I said this already, one node at a time with zero downtime. So as you add a node and you put your favorite hypervisor on it, it just joins the cluster. The storage capacity and IOPS and compute power joins the cluster. You can start running VMs on it immediately, and the rest of the cluster sees it as available capacity and starts spreading the load out onto the new node or nodes. So there's a rebalancing takes place as soon as you add new nodes. And these nodes could be of different capacity and could be of different specifications in terms of maybe newer technology, newer processors, more cores, more RAM. The system is intelligent and basically manages itself. Support is an interesting aspect too, because now there is a single hyperconverged stack which is supported right from the ground up by a single vendor. So no longer can you fall between the cracks of, well, who does the SAN, who does the SAN interconnect, be it Brocade, be it QLogic or wherever, who does the actual servers, who does the hypervisor. With Nutanix, all the way from the ground up to your application, or at least the OS for your VMs, is supported by Nutanix. Turn off my pen. So some of the, and these are backed up by actual research, which unfortunately I won't have time to get into today, but we can certainly get into on a one-on-one basis. So all of what I've said is backed up by some incredible statistics in terms of the value this brings to the business. So for instance, ROI within 5 years of 510%. The system can pay for itself within 7.5 months. Again, these are not figures plucked from the air. These are actually taken from metrics of existing customers. A 5-year TCO saving of 58%. So again, this is so simple to manage, so simple to grow. In huge cost savings can be gained. And in terms then of actual delivering the technology to the business, 85% faster to deploy, because straight out of the box we can be up and running in minutes. Adding more capacity takes minutes. Updating a hypervisor takes minutes, etc., etc. The management is incredibly simple because, again, it can be done by probably the most, not the most basic engineer, but somebody who doesn't have to have specialist knowledge or SAN knowledge. And uptime is incredibly high compared to legacy systems, because problems will occur and do occur, but you are building in small increments, and when those small building blocks fail, it has a minor impact. And the system self-heals and roots itself around those problems. Updates are non-disruptive. So updating a hypervisor is non-disruptive. Adding more or replacing failed tin is non-disruptive. Updating the firmware on the tin is non-disruptive. So really the only disruptions you will experience are planned. So we've talked so far predominantly about what hyperconvergence brings in terms of the storage layer. It's about making the storage layer invisible, so you don't have to think about it. It's there, it's highly performant, and highly available. So we've ticked that box. So now what about the virtualization layer as well? The less layers we have, the better, because it's easier to manage, easier to troubleshoot, easier to support. So Nutanix doesn't just take away the mess of the three-tier traditional architecture, where storage is a bolt-on, not designed to run really with the virtual world we live in now. And in fact, what has happened really is that virtualization vendors have had to build in storage services to their offering in order to kind of, I suppose, partly solve the problem that the storage doesn't really understand virtualization, and virtualization doesn't fully understand the storage layer. So for instance, inside some hypervisors, they've had to bring in the snapshotting capabilities, the replication capabilities and such, so that we overcome or try to overcome some of the shortcomings of having these siloed storage controllers underneath. But it really is, it's a bit of a forced fit, as we say here. With Nutanix, what we're doing instead is we are drawing those storage services back into the distributed storage fabric where they should be, so that your hypervisor gets on with its job of running your applications. And in fact, we can go a step further and actually blend the virtualization layer into the stack as well. So Nutanix, as I mentioned earlier, has its own hypervisor, which is a very customized and secured version of KVM, which is called Acropolis. And it's built in to the system. Out of the box, the whole thing boots with the Acropolis hypervisor. The management layer for that is built in. It does everything you'd expect from hypervisor, like moving VMs around, high availability, replication, et cetera, and VM lifecycle management. But you don't even have to think about it. You can boot up your 3 initial nodes, and you have something you can immediately start putting applications and operating systems on, VMs. By doing this, we're further increasing the simplicity. Out of the box, you're ready to run. A single pane of glass allows you to manage the entire stack all the way from the storage to the virtualization layer. So the only thing you need to worry about then are your VMs and your applications. Scalability-wise, you're not limited by the scalability of maybe certain hypervisors where you'd have to, while Nutanix can grow the cluster indefinitely, I think the largest cluster out there is probably something like 2,000 nodes, and that's not the limit. Hypervisors have limits where maybe you've got to create silos of maybe 16 hosts or 32 hosts. With Nutanix's system, the hypervisor doesn't have those limits either. You can basically scale your cluster as far as you like to take it. And in terms of security, because the hypervisor is part of the development cycle within Nutanix, it's tightly integrated from a security development cycle perspective. So very secure, very few moving parts. So even though it's based on KVM, KVM has a lot of fluff in there that not everyone uses. So Nutanix has highly customized the solution to include only those functions that are required and layered their own wonderful management solution on top of it, which we'll have a look at in a moment. There's also a broad ecosystem of partners who are clambering actually to work with Nutanix and become supported on their platform. So you will find vendors such as Citrix, even VMware, SAP, Oracle, Microsoft, of course, all supporting their applications on top of the Nutanix platform. And then in terms of guest support, you have the usual suspects across the Linux distros and Windows. And that ecosystem is just growing and growing and growing all the time. So we quickly just break out now the components of a Nutanix solution. So I think we've talked quite a bit to date about Acropolis itself, which is the system that creates that distributed storage fabric with all of its functionality across the storage functions like deduplication, replication, etc. And then we have Nutanix Prism, which is the management infrastructure, which really is what you see day in and day out, and what kind of is the face of Nutanix. We'll have a look at both of those. Acropolis, I think I've covered probably in depth already, in that it is, like I said, the storage fabric and the virtualization layer. So it is the hypervisor, of course, as well. Now, you do not have to use Nutanix's Acropolis hypervisor. It is there out of the box, but it's also the platform you boot into to choose another hypervisor. So you can, out of the box, then boot into Acropolis and then choose either maybe Hyper-V or VMware, and then load in your favorite ISO for those hypervisors, and it will be distributed out across the nodes so that very quickly you are running your favorite hypervisor. It's joined maybe your existing clusters, and you're ready to roll out VMs. Prism brings all of this together. So there is no Prism server. So the functionality of Prism, which is the management layer for all of this, is actually distributed across the cluster as well. So there's no single point of failure. The controller VMs perform parts of the functions of Prism. And it is, like I said, distributed out across the entire cluster. If a cluster member fails, another will take on the role of being master, etc., etc., etc. You don't ever connect your browser, which is how you manage this. You don't connect your browser to an individual host. You connect it to the overall cluster IP address, and from there on, the functionalities of the management layer are just delivered to your browser. One-click is a term you will hear over and over again when it comes to Nutanix's management, and this is something they strive towards. Everything should be one-click. So one-click management in terms of being able to stand up new VMs, create a disaster recovery plan, recover VMs. One-click operational insights, so being able to see exactly how your infrastructure is performing from the hardware all the way up through the storage tier to the virtualization layer and right into the applications you're running, in terms of being able to predict how healthy the system is, and also predict in the future how you need to scale the system in terms of adding new nodes, or maybe even downsizing or splitting the cluster maybe into test and dev. All of the information you could possibly need to plan ahead is there and in front of you. And one-click remediation. So should anything go wrong, should a node fail, you can just either automatically route around the problem, or if it's something like a disaster recovery event, you may just click, yes, I would like to fall over to or fail over to the other data center. Things like upgrades of the Nutanix software version, the hardware firmware versions, even your hypervisor version are all handled by the one-click system as well. While today we don't have time to do a live demo of how this works, what we would love to do is hear from you if you'd like to see a live demo, and we'd be delighted then to take you deeper into this console that you see before you, and get into all the nooks and crannies and show you exactly how it works and the value that it brings to you. But in one console, which is HTML5 based, runs on any browser, including tablets and smartphones or anything you like, and is all API based. So everything you see in the console is actually drawing upon Nutanix's own APIs. So if you don't like this console and you have something else already, then you can actually plumb your favorite management solution into the Nutanix APIs and gain all of the same insights, all of the same data that you can see through the Prism console. So incredibly programmable and open to automation. Everything within the Nutanix infrastructure is very VM-centric. Like I said, there are no LUNs. There's no LUN zoning, LUN mapping. All those concepts of SAN is gone. So you can get on with the task of focusing on your virtual machines and your applications. Snapshotting is done at the VM level. Replication is done at the VM level. Analytics are done at the VM level. So very easy. Everything is clicked through. So if you like to dig deeper, you click in. Click deeper until you finally get down to the nuts and bolts of maybe where a performance problem is coming from or why your application is not behaving the way you'd like it to behave. Very intuitive, very easy. And also fully delegated so that you can have individuals responsible for managing their own pieces of the infrastructure, for instance. In terms of what kind of workloads would we put on this? Well, really, up until recently, it was anything you can virtualize. absolutely anything you can virtualize will sit on the Nutanix platform and benefit from it. So a sweet spot in the early days was probably VDI because it was one of the most troublesome to get running in terms of the storage infrastructure. Very greedy in terms of storage, especially around performance and IOPS. So Nutanix was an absolute savior for anyone trying to do VDI, and still is, because it doesn't have the bottlenecks that traditional storage does. But people quickly came to learn that putting your Exchange, your SQL, your Oracle, your SAP, your big data applications, etc., on Nutanix is also the right thing to do, because even mixing workloads on the cluster does not have an effect that you may see on other storage infrastructures. So, for instance, you'll often have a problem of like a noisy neighbor when it comes to traditional SANs. So you'll have to be very careful how you zone your LUNs so that a very chatty application or a write-heavy application is not impacting on another application that happens to be on the same SAN. With Nutanix, every single node really is its own, not an island, but any badly behaving application is confined to that island. Even though it can actually talk to the entire storage pool, a problem with an application cannot spread out into the rest of the cluster. So you can have very write-intensive applications like VDI sitting alongside very read-intensive applications like analytics processes, big data, OLAP databases and such, all sitting alongside each other on the same infrastructure, and they won't compete for resources. And like I said, partners are coming on board all of the time and certifying their applications for use on Nutanix, and we'll just see that grow and grow and grow over time. So really anything you can virtualize. More recently though, what Nutanix has done is they have identified that, well, not everyone can switch over to a Nutanix infrastructure immediately. You have existing infrastructure already. You have existing legacy databases and applications which maybe can't be virtualized, or maybe it doesn't make sense from a licensing perspective to license them on virtual hardware. So what they've done in the more recent versions of the product is allow you to expose the clustered or distributed file system out to physical tin as iSCSI. So now your Oracle database, your big data application, something that you prefer not to virtualize, or something that is, it's running perfectly well on the tin you have, can now use all of the benefits of the distributed storage fabric that Nutanix offers, even though you're not actually going to run those workloads on the CPUs of the Nutanix nodes. So this now immediately means that you can fit Nutanix into your existing infrastructure without doing any kind of, forklift or out of the old into the new. You can basically bring some Nutanix in for applications that you can run on the Nutanix platform, but offer all of its storage benefits out to applications that you'd rather keep running on your existing tin, or you'd like to keep running as physical. So really, Nutanix's vision for what they're doing is to kind of make all of the layers in our computing world invisible up to the application. We want to get on with running our applications, delivering value to the business, and we don't really want to be stuck down in the bowels of the basement, making sure that our storage is tuned correctly, that the correct cables are going in the correct places in terms of our fiber channel, that the LUNs are being provisioned correctly, etc., etc., etc. We should get on with the business of running applications and scaling on demand. And this is what Nutanix does. So as they say, the best IT infrastructure is infrastructure you can't see. Just get on with running your applications. Very briefly, a little, just I suppose, look at Nutanix themselves. Founded in 2009, and like I said, mostly from people who came from that web scale world, who understood that something similar needed to happen in the outside world, in the world you and I live in, where we don't have the benefits or the budgets of Google and Amazon and Facebook. Grown rapidly. very rapidly. Current market cap, I believe, is pushing on $3 billion. Looking to IPO probably later this year. Would have IPO'd last year, but the general IPO kind of landscape wasn't good at the time, and anyone who did IPO didn't really experience a good return on it. So things are getting better, and they'll probably IPO now shortly in the next 6 to 12 months. Huge amount of customers and a presence across the entire world, both from sales, marketing, and also support perspective as well, and a highly active channel like ourselves and Trilogy, looking after customers, doing events like this, educating, demonstrating, and like I said, we'd be very, very happy to bring this further, have a chat about your own infrastructure and how it will or will not fit, and also maybe do a demonstration so that you can actually see and get under the bonnet of the technicalities of it. There is no vertical who really takes to this more than another. It's across every possible industry. So, like I said, it's just for running virtual workloads, and now also offering out scale-out storage to physical workloads as well. So everyone needs that. So one more question, actually, before we kind of wrap up. So how does Nutanix address the question of an appliance being a single physical point of failure? I think I covered that in quite detail. I mean, an appliance, it depends what you think of as an appliance. So Nutanix comes usually in a 2U block. That block is just a piece of metal to stop the nodes falling out of the rack, and it has a couple of highly available power supplies in it. So there's no intelligence in the actual block itself. That typically, that cannot fail. It's just a piece of metal. Even if it does fail, you've got resiliency across blocks. Nodes really are the compute element. So each individual node, typically there's 4 nodes in each one of those blocks. And a node can be a point of failure, and in fact, a node will fail eventually. So we compute around that. The hypervisor will, of course, relaunch any failed VMs that were on that node. That's what hypervisors do best. The storage was never isolated to that node anyway. The storage was always spread across the entire cluster. So as a VM restarts on another healthy node, its storage is present. It may all not be present locally in the local flash, but it will be shortly as it reads the data. So there is no single point of failure. And it can be engineered to be block aware, so that you can spread your nodes intelligently across the blocks. It is rack aware, so you can spread the nodes across racks. So if there's a rack failure, you can compute through that. And also data center aware. So for instance, you can actually spread the cluster across between data centers. Synchronously, if you have low latency connections between the data centers, or asynchronously if you have a wide area network link between the data centers. So this is the most highly resilient architecture you will find without buying mainframes. So hopefully that answers that question. So the title of the seminar was, or the webinar was, the 10 things hyperconvergence can bring to you. So very briefly and in summary, these are the 10 things. First of all, simplicity, I think, is the key. And simplicity brings so many other things in terms of cost savings and agility. But simplicity is the #1 thing in my mind. Secondly, this is a solution that runs any application. So whether you are the biggest enterprise or a small, medium business, or you're running, highly critical line of business applications or simple VDI desktops, this brings great value to every possible application you can think of. Costs are reduced greatly, and those costs are reduced through various different means. First of all, there's the simplicity to manage, which reduces your management costs. There's the lower cost to actually deploy in the first place, because you're not, speccing up large SANs to last you the next 5 years in the hope that it will last 5 years. You're just scaling on demand. You're also reducing a lot of costs in terms of the data center footprint. So the data center footprint of Nutanix can be about 80% less than the equivalent 3-tier architecture. So I've certainly seen reference architectures for the likes of 1,000 VDI desktops in 6U of rack space. All of the storage, all of the compute, all of the management layer for 1,000 VDI desktops rolled into the 6U of rack space. And that's just one example. Eliminates risk. So this is really about the highly available nature of the system, but also the risk in terms of planning. You know, we talked about the fact that with three-tier architecture, you've got to plan 3-5 years ahead and invariably get it wrong because technology moves faster than we can think. New applications come along, new business opportunities. So this eliminates the risk in that you can build what you need today, knowing that you can grow this in small increments forevermore, pretty much, including growing out to cloud as and when necessary. It future-proofs your IT. So you can choose your favorite hypervisor. Yes, you can use Acropolis, which is Nutanix one, which has great benefit, but you may only bring it in and test and dev initially if you don't trust it yet. So you can use your existing hypervisor and have the knowledge that you can switch that hypervisor at a later date. So there's functionality in the system to actually switch between hypervisors. You could have certain nodes running VMware, certain nodes running Hyper-V, certain nodes running Acropolis. And the system will actually translate the VMs between those hypervisors as you need. You're also future-proofing IT from the perspective of gaining the advantages of the latest technology at all times. So because we're building in small increments, we're not making a huge investment in a prediction on the future. You buy, you bought Haswell CPUs last year. You're buying Broadwell CPUs this year. Next year you buy something else, and those nodes you buy next year will have those later CPUs on board. New forms of storage will come along. So at the moment we're in that trade, no man's land between spinning disk and flash. Over time we'll move to all flash, and something else will take over as the tier one, be it 3D NAND, be it NVMe, some form of very high performant storage will take over, perhaps even molecular storage. But you're not making that predictive gamble. Over time, new nodes will incorporate new technologies. The complexity in storage is greatly decreased. There is no storage to worry about in terms of RAID and LUNs and LUN masking and all of those things. So anyone who understands a hypervisor can have this up and running in minutes and manage it easily from there on. Predictable performance. Again, very much down to the scale-out nature. We know, for instance, certainly in scale-out workloads like VDI, if you know a node can run 100 VDI desktops, you know that 2 will run 200, 3 will run 300, 4 will run 400, etc., etc. You don't reach a bottleneck whereby the SAN now puts a limit on what your compute layer can do. Compute is easy, compute is fairly linear. Storage is not traditionally. Now with Nutanix, it is. So there is no bottlenecks, no large budget, surprises is what I'd call it, every, say, 2 or 3 years. Resiliency is built in from the ground up. Because we're building in small building blocks, yes, a node will fail, but it doesn't matter. It's just a node. We have other nodes will take over the job of running our applications. Backup and disaster recovery is built in. So we can back up to another location. We can back up to a cloud location. We can do disaster recovery to another location. We can do disaster recovery to a cloud location. And that is increasing. The options are increasing as we speak. And world-class service and support is built in. So from your channel partners through to Nutanix, there are no cracks into which a problem can fall. Even if you're running VMware as your hypervisor, Nutanix will take the support and make sure your problem is solved and not start pointing fingers saying, well, that's a hypervisor problem, it's not ours. So you have that luxury or have that, I suppose, safety blanket to know that unlike with a 3-tier architecture, there's so many moving parts that finger pointing is just inherent. With this architecture, one throat to choke, as they say. So really, that's the end of our session. I think we budgeted for an hour. Apologies if we promised less, but thank you for staying the pace. And there were only a couple of questions, and I hopefully answered those. What I can do actually is, if there are people still on the line, I can I unmute anyone? No. What I would do is please do send forward any of your questions, or if you'd like to know more, like to see some of the technology, like to discuss how it would operate within your organization, we'd be very delighted to do that. So thanks a million, everybody, and goodbye.